chapter, we're looking at how to implement IP routing. We're taking a look at how the TCP/IP packets are routed inside of our networks. Also, we're going to look at dynamic versus static TCP/IP routing. The overview of this chapter, we're going to cover what is IP routing, static IP routing, dynamic IP routing, integrating static and dynamic IP routing, implementing an NT router, and also the traceroute utility. The first slide, what is IP routing? We're looking at the process, as in chapters 1 and 2, of sending a packet from one local subnet to another. In this scenario, we have two domains or two subnets configured, subnet A and also subnet B. Remember the process whenever computer A and subnet A attempts to establish communication with the foreign host, either in subnet B or C. We first of all parse or check the local ARP cache to see if we have an entry of the MAC address mapping to an IP address. If the entry is not found on the local machine, we then send out a local ARP broadcast. All the machines on subnet A would then receive this packet and verify whether or not it was their IP address, MAC address mapping. If the host is not found on the local subnet, then the information is passed to the default gateway, which is the near side of the router. The router would then parse its routing table and verify, for instance. The router would then check its routing table. Notice that we have mappings of the 8.0, 16.0, and 24.0 subnets, and their corresponding default gateways, which are the individual ports on the router as we see. If computer A and domain A is trying to communicate with domain C, for instance, computer 3 and domain C, once the resource is found not to be local to the domain, the information is passed to the router. The router would then parse its routing table and find the default gateway of where to send this packet of information. The information would then be sent to the appropriate port on the router in our scenario, which would be the IP address of 131.107.8.1, which is domain B's default gateway. Every host inside of domain B would then receive the packet, open it up, and check to see whether or not this was their IP address. Once the appropriate host establishes a match, an acknowledgement is sent back through the router to the sending host, and communication is at that point established via the TCP three-way handshake. Static versus dynamic IP routing. With static routing, routers do not share information. With static IP routing, a network administrator or someone in an administrative position needs to sit down and actually insert the appropriate routes to a foreign domain, such as 131.107.8.0 mapped to 131.107.8.1 default gateway. Every bit of this information for any host that we need to communicate in a remote network would need to be inserted manually, creating a high risk of mistyping one of the IP addresses. Notice that the routing tables are built manually, manual insertion of this information. Notice also that Microsoft supports multi-home systems as routers. A multi-home system is a Windows NT-based computer with two or more network interface cards installed on the machine. TCP/IP must be installed and bound to each individual network adapter card with an appropriate IP address attached to each one. Dynamic routing is a function of the inter-routing protocols such as RIP or OSPF. Routers share the routing information automatically. In the case of the Routing Information Protocol, or RIP, the router broadcasts its entire routing table every 30 seconds to all the other routers that it knows of. Anytime there's an addition or a deletion of a route from any router in the network, this information is broadcast to all the other routers inside of the domain. The routing tables are built dynamically. This functionality takes place automatically. It does require a routing protocol such as RIP or OSPF, which is Open Shortest Path First. Microsoft also supports RIP for IP and IPX routing. With static IP routing, as we discussed earlier, implementing two multi-home computers in this scenario, which these once again are computers with two or more network interface cards inserted. Notice that we have three domains, domain 1, 2, and 3. For domain 1 to communicate with domain 2 or 3, we must have a network interface installed as a default gateway or the near side of a router. In our case, this is an individual PC running NT server. Notice the second network interface card has the IP address of 131.107.16.2. Notice that we have communication with the 16.0 subnet at that point. The FAR multi-home computer, or multi-home computer B, has two network interface cards installed also. One IP address assigned to a network interface card, as we see, is 131.107.24.1, which acts as the default gateway for the 24.0 subnet. Notice also we have a second network interface card inserted of 131.107.16.1. So notice that the information being passed from domains 3 to 1 must pass through both multi-home computers. So both multi-home computers must have mappings back to the foreign domains. To configure static IP routing, the information must be manually inserted into both multi-home computers. Notice that the example of the routing table A, we see a mapping of 131.107.8.0, the physical subnet, mapped to an individual IP address of 8.1, which is the default gateway in our scenario. To build a routing table example looks as follows. We see a network address or an IP address or the NetBIOS name that has been assigned to the physical segment by the network admin, mapped to a subnet mask, and also the default gateway address. In review, in this chapter, we've taken a look at IP routing. We've discussed what is IP routing, which is the process of sending TCP/IP packets through a router to a remote domain. We've also discussed static versus dynamic IP routing. With static IP routing, we have a lot of administrative overhead. All the information must be inserted manually into the router or multi-home computer. Anytime we had a system crash or a failure, if this information was not backed up, we would have lost all of our routing table and it would have had to be rebuilt manually. With dynamic IP routing, the entire routing table is broadcast by default every 30 seconds to all the other routers inside of the network. So we have some redundancy, a backup strategy at that point. We've also discussed how to implement a Windows NT router